In this problem, we want to find the linear approximation for f of x equals tangent x at x equals pi over 6, and use it to approximate the tangent of 33 degrees. The formula for the linear approximation is L of x equals f of a plus f prime of a times the quantity x minus a, where a is the angle we are approximating at. As you can see, we need to evaluate f of x at pi over 6 and take the derivative of f of x to find the linear approximation. We'll start by evaluating the tangent function at pi over 6. This gives us 1 over the square root of 3. Now we need to find the derivative of f of x and evaluate it at pi over 6. The derivative of the tangent function is secant squared. Let's evaluate this function for x equals pi over 6. Recall that the secant of x is equal to 1 over the cosine of x. We have secant squared of x, so this would be equal to 1 over the cosine squared of x. The cosine of pi over 6 is the square root of 3 over 2, so the cosine squared of pi over 6 would be 3/4. This means that the secant squared of pi over 6 is equal to 1 divided by 3/4. Simplifying, the secant squared of pi over 6 is 4/3. Now that we have most of our information, let's set up our equation. We have L of x equals 1 over the square root of 3 plus 4/3 times the quantity x minus pi over 6. Since we want to find the linear approximation of the tangent at 33 degrees, we need to convert the 33 degrees to radians. So we have 33 degrees equals 33 pi over 180 radians. We can now plug this into our linear approximation. This gives us L of 33 pi over 180 equals 1 over the square root of 3 plus 4/3 times pi over 60. We simplified here, since 33 pi over 180 minus pi over 6 is equal to pi over 60, let's just write pi over 60 in the parentheses here. We can then simplify this to be L of 33 pi over 180 equals 1 over the square root of 3 plus pi over 45. This is approximately equal to 0.64716. What this means is that the tangent at 33 degrees is approximately 0.64716.